In this lecture, I'm going to talk about the middle square method. It's the first of our random number generation methods. It's not a good method, but it's a start. So, what is pseudo-random number generation or random number generation? A pseudo-random number generator is an algorithm for generating a sequence of numbers whose properties approximate the properties of a sequence of random numbers. So it's to create random numbers, but you can recreate them again and again. Pseudo-random number generators are central in the application of things you'll see in the future: Monte Carlo method, computer games for a random event to happen, and cryptography. And actually, if you look back at our cryptography notes, the algorithms that we'll look at in a few minutes are similar. Not this middle square method, but the linear congruential method. Cryptographic application require the output of non-predictable outputs, and therefore pseudo-random is the best way to do it. So we need two properties. One, that's uniform, that any number can be chosen randomly, and that the previous number looks independent of the previous one. Random numbers must be independently drawn from a uniform distribution. So if I say choose numbers randomly between 0 and 10, you can't just keep saying 7, 7, 7, 7. All the numbers should be chosen. So here are the problems with pseudo-random number generation. The generating numbers might not be uniformly distributed, the 7, 7, 7 every time example. The generated numbers might be discretely valued instead of continuous. So you might only get like integers and you want rational numbers. The mean of the generators might be too high. So if I'm generating numbers between 0 and 10, and the average of the numbers I generate is 7 or 8, then I'm missing the lower numbers. Or if the average is 2 or 3, then I'm missing the larger numbers. The variance might be too high or too low. Well, too low might be more a concern, because that means every time I'm just saying 4, 5, 6, 4, 5, 6, 4, 5, 6, that'll have the right mean, but it's very tight. Now, there might be a situation where you can predict the next number from the previous number. You don't want that in a pseudo-random number generator. You want it to be very difficult to predict the next number. The numbers are high, low, high, low. That's very predictable as well. You don't want that. You don't want a couple of numbers above the mean, a couple of numbers below the mean. You want there to be no pattern in the generation. So the two methods we look at are the middle square method, and that's what this lecture is about, and the linear congruential method, which is the next lecture. The linear congruential method, as I said, is very similar to the cryptography method, specifically the Caesar cipher and the Vigneri. So John von Neumann, who was one of the most prolific and important mathematicians of the last century, said, anyone who considers arithmetical methods of producing random digits is, of course, in a state of sin. For as has been pointed out several times, there is no such thing as a random number. There are only methods to produce random numbers, and a strict arithmetic procedure, of course, is not such a method. So John von Neumann, one of the most important mathematicians of his generation, said, stop it, don't do random numbers. But what did he do? He tried to make his own random number generator called the middle square method. And this is one step above numerology. Numerology is a belief that numbers have magicness. First, the arithmetic generate the middle square method, made by von Neumann and Metropolis in the 1940s. So what happens is the middle square method says, give me a 4-digit number, Z0, square it, and then take the 4 middle digits. Yeah? And that'll generate numbers between 0 and 999. So let's have a look at this. So if I give you the number 7182, we square it, and then we take the 4 middle digits. That's our new number. So that's our next random number. We square that, take the 4 middle digits. Square it, take the 4 middle digits, and so on, and so on, and so on, and so on. So that example seemed pretty good. So to generate numbers between 0 and 10, for example, using the middle square method, if the numbers are 1,000 in length, you divide by 1,000. to do 0 to 10. So in this example, these numbers were between, in theory, 0 and 9, 9, 9, 9. So if we divide this by 1,000, we'll have the number between 0 and 999. So that's why you divide by 1,000 minus 1. So that's dividing that number between 0 and 999. And as we know, divide 0 by 999, we'll get 0. I was like 99, 999. And if you divide 9, 9, 9, 9 by 999, we're in the right range. All right. So 999. Now, so let's have a look at what this looks like. So we have 7182. We square it, and that gets our first random number. Now, to generate the number between 0 and 10, we divide that by 999, and we get 5.812. Now, to get the next number, we use the 5,811. You have 767, divide that by 999, gets our next number. Same thing, every time, just going our way through. Yeah? So, to generate numbers between 0 and 1, we just divide by 10,000 minus 1. So that just looks very similar. That's our first number. We always have to choose the first number in the sequence. That's called the seed, and that's very important. Doesn't matter what it is, but it's the one that starts the sequence. 7182, 581, 1, 5811, and so forth. And we keep going again and again and again and again. Now, if we want to generate numbers between 8 and 11, for example, how do we do it? To generate numbers between 8 and 11 for the middle square method, just divide the random numbers by the size of the method. So 10,000 minus 1, that's our 999. That gives us numbers between 0 and 1. We multiply that by 3. That gives us now numbers between 0 and 3. And we add 8. That gives us numbers between 8 and 11. And so that means that if we want to generate any numbers between A and B, we'll be able to do it. So here's the example from 0 to 1. Now, to generate any number between A and B, we have our generated number. We divide it by 999. B minus A is the range we're interested in, and we shift it by A. Yeah? And that's our general formula for doing this. So that's how we, as I said, that's how we go from here. 11 minus 8 gives us our 3, and 8 is our A. So there's a problem with the middle square method. So after 3 generations, it looked okay. But if you keep on generating and you only do 12 times, the number you generate is 0, 0, 0, 0, 0, 0, 0. Yeah. And if you take the 4 middle digits of that, you get 0, 0, 1, which squares. So now from this point on, everything you generate will just say 0. Yeah. And that's a problem because that violates one of our assumptions. I asked you for numbers between 0 and 999,000, and you just kept saying 0, 0, 0, 0, 0 every time. That's not random. So what happens if you take a different seed? The same thing. Every time you choose a seed, it keeps on tending to 0. That's a big problem. Now, of course, the middle square method can be used to generate 2-digit numbers if you start with numbers between 0 and 999 and square them. 3 digits between 0 and 999, square them. And if you want to do 8-digit numbers, it's between 0, 99999 and square them. So the number of digits you want, that's the number you have to square. Now, the reason why von Neumann said anyone who considers arithmetic methods of producing random numbers is, of course, in a state of sin, is because his method failed. His method violates the assumptions. And that, I assume, is why he said this, because he couldn't find a method, and he was one of the greatest minds of our time. But as we'll see in the next section, there is a method. It requires a bit of work, but there is a method for doing it.